In this problem, we have a car that accelerates from rest for 15 seconds, and it has a constant acceleration of 8 meters per second squared. And this means that we're allowed to use the formulas for constant acceleration kinematics. Most importantly, are these two formulas that I would call sort of the fundamental formulas for one-dimensional kinematics. There are two others that we aren't going to use here, so I won't mention them, but they're basically algebraic manipulations of these first two. All right, so part A, compute the final velocity. Starting from rest means v naught is equal to 0. We want the final velocity. We know the acceleration, 8 meters per second, and we know how long that acceleration acted for, 15 seconds. So we just plug into the second formula here, v equals v naught plus at. Our initial velocity was 0. Whenever you see started from rest, initial velocity is 0. And I just plug in my acceleration, 8 meters per second squared, multiplied by how much time went by, 15 seconds. That's going to give me 120 meters per second. Next, I'm asked for my total displacement, and I appeal to the first equation above. And there's a couple ways to look at this. I could put the origin at the starting position, and then I could tell you x naught is equal to 0, which means x final is my displacement. It's my change in position just because my starting point was 0. Alternatively, you could look at it this way. You could subtract x naught, the initial position, and now the thing on the left is x final minus x initial, so that's, again, the displacement. In practice, the method of just saying, let's start at 0 is way more popular, so that's what I'll normally do. Either way you want to do it, v naught t plus 1/2 at squared is going to give you the answer here. So I have an initial velocity of 0, again, because this thing started at rest, and then 1/2 times the acceleration times the amount of time for the acceleration, 15 seconds squared. Notice that the units work out to meters because I'm squaring that time term. And when I run the numbers, I get 900 meters of displacement. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.